So everybody go ahead and get your notes out. Turn to day 5, even though it's day 4. Okay. So this chart right here is going to be your cheat sheet for this entire lesson. This is where we're going to write out all the transformations. So we've talked about translate, dilate, and reflect in geometry. We're going to use slightly different words when we're talking about those transformations in algebra. So this one right here means to shift left by h. Shift meaning the translate idea. So shift left by h. And then this next one is going to be shift right by h. H is some number, it's an amount that you would move your graph. Now what's interesting about these two, and you're going to put a big star right here, these stand out. There's a difference in how the others work, because when you get a C plus, doesn't that normally imply that you're going to the right or up, the positive direction? That's usually what you would think. And when you see negative, you would think you'd be going either left or down in a negative direction. But when your number is inside of parentheses, when it's inside of parentheses or inside of a function, it could be a square root. If it's inside of a symbol or parentheses, you have to reverse what you would normally think. Okay? So these are unique, that when you see the sign, you have to think the opposite of what you would normally expect. So when you see plus 4 inside of the function, you have to think the opposite of that, which is left. And the same for subtraction. You normally think left, you have to think the opposite, actually right. If you want to know more about why that is, why is it just when you plug something into a function that it's reversed, I have a little write-up on Blackboard. Not going to go too much into it right now, but if you're really curious and want to know why it works that way, I have a little write-up on Blackboard that you guys can look at. I think it's in the course materials. Cool stuff. Alright, so this is our left versus right. What do you think these are? Instead of inside the function, they're at the very, very end of the outside. What do you think those would do if you add something to the end? We took care of left and right. Up and down. So if you add something to the end, that's going to shift. It's going to shift up by k. Because this number is not inside of the radical, you can think the way you normally would. Because we're adding, you go up. You don't have to reverse your thinking. What do you think it would happen if you were subtracting at the end? So shift down. So when it's inside of the parentheses, inside of the function, you have to reverse it. But if it's outside, you can leave it the way you would normally expect. So add k to the end is up, subtract k to the end is down. Okay, so that's your translation. Now we're going to do our reflection. So if you guys multiply your function at the very front, so it's going to look like a coefficient. If you have a coefficient at the very, very front, and that number that you're multiplying with is between 0 or 1, so it's like a small fraction, that's called a compression. Compression by whatever a is, and then in parentheses, I want you to write vertical. You guys want to write an example? An example would be 1/2 x, or 2/3 x, or 1/4. As long as your fraction is between 0 and 1. Okay? Now, I am specifying that this is a vertical compression because there is such thing as a horizontal compression that we don't hear about. So a vertical compression is, imagine a trash compactor, right? Normally they're this way, but imagine a trash compactor like this. You have these two metal arms with a graph inside. As you pull these arms down to compress, what do you think happens to the graph? It's flattens out, gets squished. So that's what we're going to be seeing for a compression. Imagine that you're compressing a graph like this vertically, it's going to flatten out and stretch like that. Then this one, if you multiply the front times a number that's greater than 1, so let's say 3, no longer between 0 and 1, it's not going to be a number bigger than 1, that's called a stretch. Stretch by a, and again, this is only vertical that we're writing. So stretch, instead of the arms coming down, the arms are actually going to take your graph and pull it up. So instead of flattening out, it's actually going to get steep. It's going to close in on itself. It's going to get steeper. So make sure you guys have the connection between the fractions between 0 and 1 and your compression, which makes it flat. And then your number is bigger than 1 and your stretch pulling it together so it's steeper. This is your dilate from geometry. And then lastly, these are our two reflections. So if you guys multiply the front, the very front with a negative, that is a reflection over the x-axis. So you can have that negative at either the front on the outside, or you can have it in front of the x on the inside of the function. So if it's outside of the very, very front, that's a reflection of the x-axis. If it's inside of the parentheses of the x, that is a reflection over the y-axis. Okay, so we have our translate, dilate, reflect. We don't care about rotation. Right? So our first part of our learning targets is to be able to look at a function and decide what transformations are happening. So that's what we're going to do here. We have a bunch of different examples. We're going to look at the examples. We're going to figure out what transformations are happening. Now the best way to do this is to circle everything as a transformation and then name them in order. So in your function, the things that are not going to be transformations are the f, the function symbol, and x. Everything else is transformation. So you have this negative right here. We have this -2, and we have this +5. So we have 3 different transformations. I need you guys to tell me what they are. What happens when you have this negative at the very front? It's a reflection over what? X. Abbreviation. So we're going to reflect over the x-axis if it's on the outside, very front. What does that -2 on the inside do? We're going to go to the right 2. When it's inside of parentheses, when it's inside the function, you have to think the opposite. So when you see minus, instead of going left, you go to the right. So you have to be careful with that. Then we have 5 at the very, very end. What happens when you add 5 at the very end? Up. Up 5. Inside the parentheses is left versus right. At the very, very end is up versus down. Okay? That's our first. What in this one is a transformation? What would I circle? Okay, so this is the transformation. This is the transformation. And then the 2 is also a transformation. So everything that's not f of x is a transformation. So what is the 2 at the very front? What does that do? What transformation is that? It's stretched because 2 is greater than 1. So when you multiply by 2, that's a stretch by 2. Alright, what does the +10 on the inside do? You go left 10. Again, when it's on the inside, you've got to think opposite. Opposite of what you would normally do. And then on the outside, where you can think normally now, you can think of what you would normally expect. What would happen if you subtract 3? Down. Again, inside the parentheses is left versus right. We have to think opposite. Outside, at the very end, is up versus down, where you can think like you would normally expect. Alright, this one, what do you guys think? How many transformations are there? How many? 1. No. There are 2. There are 2 transformations. What are my transformations here? Can anybody explain why there's 2 instead of 1? The negative is separate from the 1/3. Okay? When you guys look up here, see how I said the fractions have to be between 0 and 1? Doesn't imply that they're positive? So all of these coefficients need to be positive. If there's an extra negative, that's something totally different. Separate. Okay? So separate from the 1/3, what does the negative at the front do? What does the negative do in any case? Okay, so any negative is going to do a reflection. You just have to figure out which axis. If it's on the outside. Alright, what does the 1/3 coefficient do? Compress. It's between 0 and 1, so it's a compress. Compress by 1/3. The small number between 0 and 1 is compressed. Alright, let's get. Now, I know that what's on my screen is different. So you guys have to do this. Let's fix it really quick. I changed it for next year because this kind of thinking we're about to talk about is a little bit tricky and beyond what we need to do, but we're going to talk about it anyway. So, I have, is that right? What everybody has? Okay. So, how many transformations do I have? Where are they? Another thing. Negative. 3. Okay. Now, for this one, you guys notice how the negative is inside the parentheses? So, what does this negative do? Reflection. There's a difference between negative and subtraction. So, when I say negative, it means you're multiplying. That's reflection over which axis? So, the inside, so do the y-axis. Because it's inside the parentheses.
Also, it's like,
Yes, when it's outside is x, when it's inside is y. Alright, so this is where it gets a little bit weird. When you guys look at this now, when I ask you what the 3 is going to do, what would you say based on the pattern from the previous? You'd say left 3, right? But what's different about this example compared to the other ones on the inside of the parentheses? X is negative. So if over here, when the x was positive for all these examples, and we had to think opposite of our normal expectation when it was positive, what do you think happens when I make the x negative? You don't have to think opposite anymore. So if they have the negative on the inside of the parentheses, it kind of wipes away that expectation of thinking opposite, kind of counteracts that, like a double negative. So if I have this negative here, without the negative, you would be totally right to be going left. But because the negative is here, I'd really be going to the right. So it's an extra complication you guys do need to be paying attention to. This is like a double negative. If you have a negative inside, you no longer have to think opposite of what you would normally expect. So maybe write in the margin somewhere, if there's a negative inside the parentheses, don't. Maybe up next to the 2 where we would at the top, if there's a negative inside the parentheses in front of the x, you don't have to think opposite. Yes? Say one more time. Like if it was negative x minus 3, then I'd just be going left. When I say negative, I'm referring to multiplication in front of the x. Or if there was reflection on the other side, it would be in front of the x. Okay, make a note if you think you're going to forget that. Then what does the plus 11 do at the very end? Up. Okay. Before we do the bottom row, I want you guys to talk to each other to recap. So you're going to pick one of these and go through the entire process of explaining it to the person next to you. And then if you have a question, all right, pushing onward. What's the transformation or transformations here? First of all, how many are there? Where is it? What does it do? Alright, this one, how many? Where are they?
1/3 plus 2 -3.
Okay, what does the 1/3 do? Press by 1/3. Okay, inside it's positive x, so if I have a plus 2, go left. This one you would think opposite. What is that, a 2? Yeah, it's over, I couldn't tell. Alright, then on the very, very end I have subtract 3. Right, how many do I have here?
1.
Where is it? Alright, what does minus 2 turn into inside of the parentheses if the x is positive? So, right, opposite of what you would normally expect if the x is positive. Alright, I'm going to do it again. Should we bring that? Sorry. Okay, so I just accidentally. Okay. So, how many transformations are there? There are 4. Where are they? The negative, the 3, the negative for the x, and then the minus 4. Remember, if you guys have a coefficient and a negative, they're split. They mean different things. Any multiplication with a minus means something different than the extra part of the coefficient. Alright, so what does the subtraction do right there? So the first, we're going from left to right, so the first one is a, what does that mean? Yep. Reflect. What does it do on the outside? X axis. Alright, what does the 3 do?
Good.
It's more than one. So a big stretch. That's by 3. Alright, what does that negative in front of the x do? It's another reflect, but this time with axis. The y. And then now, be really careful. We have a negative in front of the x on the inside of the parentheses. Now when I ask you what the -4 does inside the parentheses, it's not opposite anymore. So what would it be? Left. So again, if you haven't written this down, you think you'll forget it. Make sure you take into consideration that when there's a negative in front of the x inside parentheses, you no longer have to think opposite when you're trying to find left versus right. Okay? The only time. So do you have any questions on this part of our learning target? This is learning target where you guys see a function and tell me what the transformations are. Any questions? No, all the stretches that we're doing are vertical. We don't really, there is a such thing as, there we go, as a horizontal stretch and compression, but we don't have those. Alright, the next thing that we're going to talk about is now looking at a graph, figure out what the transformations are, and then after we do that, how do we write the equation of the graph, right? In all the previous examples, we have an actual equation. This isn't an equation anymore, it's a picture. So we're going to figure out what the transformations are by looking at the picture and then figure out what the equation would have been from there. So, alright, what you guys want to do is pick a central point on your graph. Alright, those are corresponding. So the central point here is going to correspond to the central point on the other graph. You just want to see how did it get from point A to point B. This is called a parent function. A parent function is a centered, non-transformed version of the graph. So this is what your original graph will look like, and then any additional transformations will create non-parent functions. Alright, how did I go from here to here? I had shifts. What are they? Okay, I went right by how much? By 1, then left. Then I went down by 2. That's how this point ended up here. So everybody see that? You can count on your coordinate plane. Cool. Alright, do you guys notice anything else different about this graph besides just where the point was? You have flatter. So what do you think happened? What transformation? Compression. So we're going to write compress. But in order to write the equation, I need to know how much was it compressed. So if you guys are trying to figure out how much it compressed, we're going to be using slope. Okay? So what you want to do is compare the slope between the first central point and the point, I can't draw small board, sorry, between the central point and then the point right next to it. So what's the slope from that point to the second point? You go up 1 over 1. Okay. How do I get from the central point here to the next point, the next exact point? That graph. I had to go up 1 over 3. So that's your compression. So the slope between, it's how you rise from one point to the next, from the central to the one to the right or to the left. That is your compression factor. Okay. So I have 3 transformations. How would I write that in function? I'm going to start with F. Yes.
This was the second one. Like, we didn't just add, like, anything with this for the first.
Maybe if you go up one again. We're just going up one again. Alright, so how would I write this as a function, just like I did with those examples? How do I show right one? Parentheses. X minus 1. Okay, so we have the first one. We have the right one with the thinking opposite, right? How do I say down 2? Minus 2 at the very end. And then how do I say compressed by 1/3? 1. Multiply 1/3. Okay? So when I ask you to write the equation of a graph, find the transformations first by comparing the pictures, and then plug them in where they should go within the function. Let's try this one. Here's my central point, right here. And I moved right there. How?
Just do left of one.
Okay, I went left 1. Take a 3. Okay, then I went up 3. That's how the point moved from point A to point B. Now, is there anything else that changed? It reflected, right? So up, now flip down. So which axis do you think I reflected it over? If I go like that. The x-axis. Because they're going right, x-axis is here, if you're flipping like that. So I reflect over the x-axis. Are those the only 3 things that are happening here?
No, it's not straight.
Yeah, see how it's kind of a little bit skinnier than the original? What transformation would make it skinnier? We said the compression makes it flat, so it gets fatter. What transformation would make it skinnier? Stretch. We're pulling it like this, which pulls in the sides together. So it is going to be a stretch, and you guys are going to find the stretch the exact same way we did for compress. You're going to compare the slope. So if I look at the original, they go from the central point to the one next to it, I go up 1 over 1. Okay? Then if I go from the central point to the next exact point on this graph, what do? Go down 2 over 1. So now, instead of the slope being 1, it's going to be 2. Ignore the negative part. We already take care of that with the reflection. So just worry about the numbers on the side. So because it now is a vertical stretch of 2 instead of 1, that's going to be our stretch factor. Okay? So I know technically the slope is negative 2 over 1, but again, the negative is already going to be taken care of with the reflection. Alright, so let's write the function. There's my f. Okay, so that's how we get the left. And plus 3 is our up. That's the reflection. This is the stretch. So that would be the function. Are you guys kind of seeing how we're doing that? Okay, go ahead and try the last one now. Alright, so on the first one, so bottom left, how do I go from this central point to this central? I know this line is kind of faint on the graph, the central point is right there. How do I get from the first one to the second one? Right, 2, and down 3. Is there any stretch or reflections or anything going on? You can double check by, again, checking that slope up 1 over 1, up 1 over 1. So if that original slope from the central point to the one next to it is the same, nothing happens with the check. Alright, so what would my function be? Opposite of what you would expect inside the parentheses. Back down. Again, inside the parentheses for left versus right, you have to write the opposite of what you would normally expect. Okay, keep track of that. But then this one, so there isn't really a central point. You guys probably just want to pick like 2 good ones, here and there, and then here and here. So, how did I? And another way you can think about it is you can see how it's kind of flat right here and it's flat right here. So there's another way you can think about it. So, what shift does that make? I went down 3. See how my point shifted down 3, each of them, and the flat line also shifted down 3. What else changed? It flipped, right? It's reflected, but over which axis? This time it's the y-axis. So if you go like this, flipping like this is the y-axis. Alright, that's it for that one. So how would I write the equation? Okay, so there's the negative for the reflection on the y-axis. Now this we have to be careful, remember? When the negative is in front of the x on the inside, no longer has to be opposite of what I would normally be doing. But I'm not going left or right, so that doesn't matter. Close parentheses. And then how do I say down 3? If I'd also gone left or right, you guys would have been able to finagle that with the not having something opposite. So that was one of our other learning targets, looking at a picture, being able to tell what the transformations are. So that was both sides of the coin, looking at the function to determine the transformations, looking at the picture to determine the transformations. That was our first learning target. So are we okay with both of those things, getting the transformations from both the equation and the picture? I know it's a little bit more abstract with the picture. It's got to take a little bit more time. And then one of our other learning targets was being able to write the equation, once you do the transformations. Is that also okay for people so far? Okay. So our next learning target, our third learning target of this lesson, is being able to graph it. So if I tell you what the function is, can you graph it? So that's what we're going to be doing here. So we're going to graph, the parent function, the one that's centered, is provided for you guys. And then the equation of the transformed function is also presented. We're going to graph it. So the best way to do this is to write down what the transformations are and then do it. So, what are the transformations? Right one. And up two. There we go. Alright, so whatever your transformations are, you're going to write them down. And then we're going to take some points on this graph. Those points can go here, here, and on the original. Then you're going to do the transformation. I'm going to take each of those points, I'm going to shift them right one and up two. So, if my original point is at the origin, if I go right one and up two, my new point would be right there. If this point started at 1, 1, I put my pencil here lightly, I go right one up two, and it goes right there. This point started at 4, 2, I go right one and up two, it goes there. So find the original points, and then do the transformation for each of them one at a time, and then connect the dots. Alright, so that one's really simple. This one's like, ooh, super complicated all of a sudden. So, what transformations do I have in this one? Here, answer this slightly easier question. How many are there? How many are there? 4. There are 4. What's the first one? The very front. Is there a reflection over the x-axis? That's the negative. That one. Nope. 2. What does a 2 do? Stretch. Side 2. What is the plus 1 inside of the parentheses 2? Left, so think opposite, so left one, and then the minus 2 at the end. We have 4 things that we're going to need to do, so we're going to have to keep really careful track of our point as we're moving it around. So let's find some good points in this graph. Let's do this one, and let's take a nice spread. Let's do at least 3 points if you guys are. Let's start with the origin, okay? We're going to start at the origin and then go through all of these transformations, kind of dragging our pencil around until we get to our final destination of the graph. Okay, so here's our first point. 0, 0. I'm going to reflect over the x-axis. See how I'm on the x-axis? If you're on the x-axis, you can't reflect over it. You're stuck. Forget that. Alright, stretch by 2 means that you guys are going to multiply the y value. Remember, it's only vertical, stretch and compress. You're going to multiply the y value by 2. Well, what's the y value of this point? This point is 0. What happens when you multiply 0 times 2? Stays 0. So those two don't really do anything to move our point. Then I'm going to go left 1. Boom, I'm here. Then I'm going to go down 2. Boom, I'm here. That's my first one. See, reflect and stretch didn't do anything because I had 0s. Then I go left 1 down 2. Okay? Now I'm going to start at this point right here because I'm going to put my pencil right here. Right. I'm going to reflect over the x-axis. That means you're going to go on the opposite side of the x-axis. So if I'm above, I'm going to go below. Right here. Right? So that's the same thing as down here. Reflecting over there. Then I'm going to stretch by 2. So what's my y value where I am right now? Negative 2. Multiply that times 2. So only the y values that are changing. Then I'm going to go left 1 and down 2. Slightly off track. Sorry. We'll pretend that that's negative 6 right there. Okay? So that's where this point is. Now we just have one more point. This one starts at negative 2, 2. So I'm going to put up and go right there. Okay? One at a time. I'm going to reflect over the x-axis. So that means if I'm above the x-axis right now, I need to go below it. So I'm going to go right there, same distance away. Then I'm going to stretch by 2. So the y value on that right now is -2. Multiply that times 2, and I got 2, -4. And I go left 1, down 2. Once you have those, make it out. Yes. Yeah. Anytime it goes up to the edge of your graph, it's implied that it goes up. Alright, so depending on how many transformations you have, it can be time consuming. But on its face, it's relatively simple. You just have to keep track of where your point is. I'm assuming everybody remembers how to reflect over x and y axis because you did that in geometry. Alright, we're not going to do this one. That has asymptotes and stuff. We don't really care about that right now. So we're going to go on to this cubic function underneath the one that we just did. Alright, what are the transformations that I have here? Okay, it's different. Let me fix that. So this should really say this. Okay, fine. What are my transformations? Okay, so we do have an echelon. Well, let's write them in order that they're. Reflect over the y-axis. Left. Alright, so remember when the negative is inside the parentheses, you no longer have to think the opposite of what you would normally think. So this is the left one. And then, oh, sorry, 2. Then, write these out. Now we're going to put the point. Your center point is at the origin, like it tends to be for these graphs. Alright, so start at the origin with your pencil. Alright, I'm going to reflect over the y-axis. Do I go anywhere? Nope. I'm going to go left 2, boom, boom, and I go up 1, boom. Okay. Alright, the next point is going to be here at 1, 1. That's the next exact point on my graph. I'm going to put my pencil there. When I reflect over the y-axis, I'm going to go on the other side of the y-axis, which is right here. Okay? Then I'm going to go left 2, boom, boom, up 1. And then the next point immediately here, I'm going to use that one right there. On the original graph, I said -1, -1, which is right here. I'm going to reflect over the y-axis. I'm going to go here on the other side of the y-axis. Left 2, 1, 2, and then once you have those points, you're going to need to draw the graph. That doesn't go very well, but it should look something like that. Okay, because it was reflected over the y-axis, it's no longer rising to the right, it should fall. Okay. So we're going to stop there. We'll continue practicing with the graphing next time, and then there's a little bit more practice on the next page of the tutorial. For this situation, we were really using the function in the previous examples to determine how to actually do the transformations. So they're listed here, so they've kind of taken that step out, but I still think it's a really good idea to write it as a function, kind of just to give us an idea of the arrangement of the transformations in the function and how, what order we should use when we're actually doing them. So, if we take the transformations in this example on the left and write the function. So we have the flipping over the x-axis, so it's the multiplication of a negative on the outside. It's going to reflect over the y-axis, which is a negative in front of the x on the inside. Now remember, when you guys have a negative on the x that's inside of parentheses, you no longer have to think opposite of what you would expect for left versus right. So if I'm going left 2, you can leave that as subtraction. Again, because the negative right here lets us think like we normally would instead of the opposite. So -2 to indicate the left, and then up 4 would be +4 right there. So this is our function. Now we're going to look at our points on the graph. I'm going to pick this one, this one, and this one. Just going to shift those points according to the transformations and then show where they would be on the other graph. So if I start at the origin, I'm going to draw little small dots for how our points are moving, and then I'll draw a bigger one for our final point after all the transformations are done. So start at the origin. If I do the first transformation to reflect over the x-axis, so right here, it's on the x-axis, so it won't move. If I try to reflect over the y-axis, it's also on the y-axis, so it won't move there either. But then I'm going to go left 2, 1, 2, and then up 4. 1, 2, 3, 4. That's where our point is going to be. Our first one. Okay. Now we're going to take the point on the right, so it starts at 1, 1. We're going to reflect over the x-axis, so it's going to go here. Reflect over the y-axis here. Then we're going to go left 2, 1, 2, up 4, 1, 2, 3. That's our destination for that one. And then for the point on the left of the parent function, remember parent function is before you do any transformations. So the left point is going to start here at negative 1, 1. So if I reflect over the x-axis here, reflect over the y-axis here, I go left 2, which gives me back here, and then I go up 4. 1, 2, 3. So once we move our points, draw the view, and that's what the final function would be after the transformation. And then lastly, for this one, again, we're going to go ahead and write the function. So if I'm flipping over the y-axis and going up, it would just look like this. So now I'm going to take this point and this point. Those are going to be my points I'm going to use. You could also do this third one if you want to. Actually, let's do that third one. I think it will help us figure out how the graph should be drawn. So those are our points. So I'm going to start with this one, the first one on the graph. I'm going to flip over the y-axis. So because it's on the y-axis, it's not going to move. And I'm going to go up 1. Go right here. Alright, our next point is going to start here. So this point right there. I'm going to reflect over the y-axis. I'm going to take it over here, and then I'm going to go up 1. I'm going to go right there. I'm going to erase the little one. Okay, the others. Okay. Then our last point is going to be at 2, 4. Right there. This one. We're going to reflect over the y-axis. It's going to take me here, and then I'm going to go up 1 and take me here. Now we're going to draw our curve, look like this. Another thing to notice is that this graph, the original picture, it stayed flat along the x-axis. The horizontal line, you want to kind of imagine it going up with the graph. So because I'm going up 1, that horizontal line also goes up 1. So that's why our graph isn't going to continue down into this space. It has to level off at that horizontal line, just like in the original picture. Okay? Make sure you carry along all aspects of the graph when you guys are doing transformations. Alright, so that's our third learning target, being able to see a function or see a description of transformations and graph the picture. Okay, just a little bit more practice with some of the things we've talked about already. So this one right here, we're going to write the equation again, but we're going to be writing the equation from the description of the transformation. So it's kind of like what we did for this example, this one. We're just going to do a little bit more practice. So for our first one, they have that we're going left 2 and up 3. So remember that when you're going left or right, you have to write the opposite of what you would normally expect. So I'm going to write x plus 2 inside the parentheses, and then up 3 is outside of the parentheses with addition. So plus 3 at the end. Our next one, we have a reflection over the x-axis, which is always a negative on the front or outside of the parentheses. Then I have right 3, so think opposite of what you normally would, and then down 4, which would be subtraction at the very end. The next one, we have a vertical stretch by a factor of 3, so when you are stretching, you're going to multiply the very, very front by that number that's greater than 1, which is right here. Looks like we're not going left or right, so you can just write x and stop there. So we are going down 7, so you can say minus 7. Over here we have a flip or reflection over the y-axis. Oops, this one is also missing something, so should also say 2. Go. Alright, so if I'm going to have a flip over the y-axis, remember that is a negative in front of the x on the inside of the parentheses. Remember, when you guys have that negative inside of the parentheses there by the x, you no longer have to think opposite of what you would expect. So if I'm going left, I can put a minus 2 here because of that negative in front of the x. So you don't have to think opposite there. And then I'm going to be going down. That would be cool. This one we're going to be reflecting over the x-axis, so the negative is on the outside of the function, and then I have a vertical compression, which is also on the outside being multiplied. So you have the negative, which is the reflection, and the 2/3, which is the compression. So remember that those pieces mean different things. And then this last one's a little bit of a doozy. It has pretty much everything that we've talked about so far. So I'm going to be flipping over both of the axes. So that means I'm going to have a negative on the outside and a negative on the inside. So I have this so far. I have a vertical stretch by a factor of 2. So the stretch factor goes in the front. I'm going to be going right 5. Now remember, we said that we have that y reflection, or reflection of the y-axis, that gives us this negative here. So remember, when the negative is on the inside, you don't have to think opposite anymore. So I'm going to put plus 5 to go right, and then plus 6 to go up. And then on this last page, we just have a little bit more practice. Oops. Super. We have a little bit more practice with figuring out what the transformations are just by looking at the graph. So we had to do this in order to write the equation when we saw the graph, like on the previous page. So we're not going to write the equation, we're just going to find what the transformations are and stop them. So again, you want to compare where your key point goes. So that's my key point there, and this is my key point here. Kind of see they're in the same position. You could also, again, see that horizontal line here and here. So you can use that as a reference point too. So I noticed that what happened is that this graph was kind of flat and then going up, but this one is flat and then going down. So we can see that they switch directions. So this one's going to reflect over excuse me, the x-axis. Right, now to determine how much it's been shifted up or down, you can see that our horizontal line for the graph on the right is 3 above the graph on the left. So that means that it went up 3. So our graph flipped upside down, it went over the x-axis, and then it shifted up 3. So those are our 2 reflections for that one. Alright, our next one. So we have our center point here and then our center point here. So you guys can see that from the parent function, this is where it started. It went left by how much? See, that looks like 3. So left 3, and then it also shifted up 1. So, and then there's nothing with the stretch or compress, there's nothing with the reflection. So those are the only 2 transformations. Over here, our key point, our central point is right here, but it's right here for this graph. So again, we can kind of analyze how do we get from point A to point B, right? So it looks like we went to the right. Let's count. So we went to the right, it looks like 3. We went to the right 3, we went down. Let's see, 1, 2, 3, we went down 4. So we went to the right 3, and then we went down 4. And then also, it's not going off to the right anymore, now it's going to the left. So that means that we flipped over the y-axis. So this also has a left over the y-axis. So analyze how the point shifted. How did you get from the center or main point on this graph to the main point on the other? You want to check to see how they moved, and then check to see if there's any stretch or reflection going on. This last one, again, it has asymptotes. We're not really worrying about this too much, but if you look at the kind of crisscross that's defining the barriers in this graph, that's a good way to determine what's happening. So if you kind of think of this center point right here shifting, you can kind of see how it was originally at the origin. Sorry, I did that a little bit messy. was originally at the origin, and now, if you look at my paper, it's at -1, -3. So it went left, 1, and down. So again, that's one way that you can use these pictures that have asymptotes. You can use the crisscrossing lines that you would draw, and then where they meet is the central point that you would look for.